So I'm here today with Larry Peterson. Larry, I'm drinking coffee as is my normal habit. I'm guessing it's a bit late in the day for you for coffee?
Well, it is. It isn't too late for a brew of some kind, though.
All right. Well, if you want to go and pop off and get a beer, feel free. For those of you who don't know, this is Larry Peterson, my co-author on Computer Networks and Systems Approach. And Larry and I have known each other since I think, early 1990s when we collaborated on a networking project. I guess before I go into giving more background about you, I want to know about your cat, since the cat theme has been showing up a lot in some of my videos.
He's going to be interrupting here at some point. This is Toby, if you can kind of see him there. So we live in the desert, which is full of coyotes, and Toby's used up a couple of his lives. Right outside in our backyard, there's a wall, and the other side of that is open desert. And when he was a few months old, a pack of coyotes came to the yard and got him and took him over the wall. My wife went out, started yelling at the coyotes. We think he has some coyote DNA in him now.
All right. Yeah, so I have a lot of warm memories of, literally warm memories of visiting you in Arizona. I also remember working with you on a joint research paper sometime in the early 90s. And I was locked in my house during an ice storm in New Jersey, and it was literally unsafe to go outside because there was so much ice on the roads. You were probably soaking up the sun in Arizona, but it was one of those kind of early experiences similar to what we're going through now, where we actually could leverage networking to collaborate from a pretty remote distance. So Larry, I think you've actually been in networking longer than I have, and you're aging very well, but can you maybe tell me a little bit about kind of your early experiences with networking?
Yeah, let's see. Well, I was a grad student at Purdue back. I remember the transition from the ARPANET to the internet. And my advisor actually handed me a 9-track tape for our VAX that had TCP. He said, there's this thing called TCP IP on it. So yeah, that was my first exposure to it. And I was just thinking about that, and you were talking about being connected from home. You also got it connected from your university. Back in the day, when I first moved from being a grad student to the University of Arizona, where I was on the faculty first, at that time, except for the few DARPANET, internet sites, most universities weren't on the internet, and so the first thing I did was got us on a 9600 baud leased line network called Cypress that connected to the internet. And that was the first time a lot of universities got connected to the internet in some way other than dialing into CSNet to get your email. That's a long time ago, 9600 baud.
Okay. And so, I think you and I worked on this project to build what was at the time a high-speed network that was supposed to operate at about 1 gigabit per second, which it honestly was pretty high speed back then in the 90s. And I remember after having done that for a bit, and that was how I managed to get my winter trips out to Arizona to come and work with you and your grad students.
We had a thermal networking lab. I don't know if you remember, but it was.
I do actually, yeah.
We had a can of Freon that we were spraying on the board that you built, the ATM. Nick.
That's right. I do remember having a piece of hardware that was working perfectly in the cold weather of New Jersey, but stopped working in the heat of Arizona, and Freon was the.
We had to cool it down to keep it running.
Yeah, so I think must have been at 95 that you were starting work on the book that would eventually become Computer Networks: The Systems Approach, and realized maybe that you'd bitten off more than you could chew, and that's my recollection of how I came to be your co-author.
Yeah, I definitely had bit off a lot. And and I think we met at a conference where we started to also collaborate on the gigabit testbed at the time, and figured out a way to divvy up the work and get it done. That was great.
Yeah, and honestly for me, that was like one of the great early experiences for me of like having to learn networking well enough that I could explain it to somebody else. And I remember working very long hours in that period to get the book out, because as I think we both discovered, it's a ridiculous amount of work to write a book. And that book in the first edition was like 600 pages or something. And so, I always would be, slaving away late at night and on the weekends thinking, it's going to be so great when this is done and people can read this book and, actually learn from us without us necessarily having ever met them in person. And I guess here we are, 25 years later, and the book's heading into its 6th edition. So I guess that was a good investment.
Yeah, absolutely. I still find, until you can explain it to someone, you don't really understand it yourself. And even in what I do now with working with a lot of engineers in open source software, they're building wonderful systems. But it's when they reduce it to the tutorials and really write it up that they refine their thinking and explain it in a way. And it influences how they build the system as well, that they can explain.
Yeah, I guess the other thing I figured out is you can get away with a few mistakes when you're explaining something to a person one-on-one, but if you put a mistake into print, you're absolutely going to find out about it. I made some absolute clangers when I was first learning about security that were very quickly pointed out to us once the book was in print.
The good thing is there are plenty of people to tell you where you went wrong.
Yeah, and then fortunately you can reprint. So it's not like we're doing brain surgery.
In terms of reprint, right now, we used to do editions, I don't remember now, once every 3 years or so. Maybe it was even more than that. Since we've gotten the source to the book and put it online, we now are doing agile book writing. So
yes,
every time I find a mistake or I figure out something I could say just a little more clearly, I'm able to get it up on the web, make the edits, compile it, get it up on the web in a matter of minutes.
Yes, I mean, it is great that we've got the entire book online now. And I think it also, both of us having had some experience with open source software, I think I had this realization in about 2012 that open source was the right model for a textbook as well as for software. And it took us a couple of years to persuade the publisher of that viewpoint. But I think we've definitely got some benefits now having the book available freely online.
Yep. Bruce, I think it's time that I get the cat out of my lap here and maybe.
Okay. That's fine.
In just a second.
Okay, sure.
Cheers.
All right, now you've really made me jealous. Cheers. It's a little early for the beer here in Australia. All right, so I guess I wanted to ask you what you're working on these days, aside from 6th edition of our book. What networking projects are you working on?
Yeah, well, I officially retired, went emeritus from Princeton a few years ago, and have been with the Open Networking Foundation since then. They're kind of the heart of the SDN movement, as you know. They were spun up and out of Stanford and Berkeley, and Scott Shanker and Nick McEwen were principals in that. And the ONF is doing open source software, and it's really trying to push the edge of what's possible with SDN, software-defined networking. The place that we're pushing it right now is into the cellular network, into 5G. So it's been interesting. I've had to learn a lot about 5G, or just about the cellular network. If you go back and look at our early editions of the book, we never really talked about it. It was just a little bit of an aside. And so it's an entire new space. There's an entire network that's been out there just as long as the internet has, and has evolved in its own ways, independent of everything that we know on the internet and the IETF. You kind of think of it as the access network, that part of the last mile, but it's really going to become a more integral part of the internet. You could argue it will be the most important part of the internet going forward. Yeah, probably at this point, some pretty significant percentage of people accessing the internet are doing it over the cellular network, if not yet over 5G. Yeah. And I mean, it's not just the cellular part of it or the 5G part of it, which is hugely important, but it's the way the internet has flattened. And so you and I are not connected directly to each other over the internet. We are both connected to our nearest cloud site. And so it's basically that hop from my on-ramp to the cloud and your on-ramp to the cloud, and the cloud's doing its own thing behind the scenes with its own backbones. And so the only piece left is the access network, and that's increasingly cellular, or increasingly 5G. Yeah.
I mean, it's an interesting point there. I did want to sort of touch on how things have been going since we've both, and like most of the world now, we're really dependent on aspects of networking to get us sort of through the period of lockdown. And, so here we are today on a Zoom conference. And as you say, like, it's not like there's a direct internet connection from me to you. It's actually, we're using a cloud service, which apparently is working extraordinarily well.
It seems to be.
So I guess, you and I have been involved in trying to get networks to work since a point in time where they really didn't work so well. You know, we certainly weren't very successful in doing video conferencing, you know, 25 years ago. What do you think has kind of changed in the 25 years to make video conferencing so effective?
Well, I mean, certainly having enough bandwidth to do it has helped a lot, but I think it's probably mostly just is the coding speeds of the capabilities of the edge devices. We just never thought we could run the encodings fast enough to really do anything practical.
Yeah. I mean, I think that's certainly, again, you're talking about things we had to learn for the book, like, you know, understanding how video coding works. That, you know, I think that continues to get better, and this idea that, you know, there were people who understood coding and there were people who understood networking. There were very few people who understood both. And I think that's one of the things which I think is really extraordinary today, even compared to 5 years ago, that the way to do video and audio coding in a way that sort of adapts to the things that don't necessarily go perfectly on the internet. You know, so like, you know, there's a lot of latency between you and me right now. It's just like unavoidable given the speed of light. And that latency varies, and yet, you know, we're able to converse reasonably comfortably. And I think, you know, a lot of the things that are making that work are, yes, when the packets get delayed or dropped, there's adaptive coding that's going on to make the experience as a user pretty seamless.
Yeah, and it's optimized for voice, right? If we were, a lot of people are using Zoom for a lot of different things right now. So you've seen concerts and music and music teachers teaching their students over Zoom. The voice codecs don't work so well for that, but I just learned myself because I was trying to use Zoom like that with my son, and there's a setting on Zoom that will I forget what it's called now, but it's you get out of the voice codec and you can actually get a much wider range of audio out of it.
All right, I didn't realize that, but yeah, that's the thing. Yeah, coding it's a very, you know, very advanced science now. That, yeah, coding for voice is as you say, a different thing.
It must be incredibly optimized. I don't know an awful lot about it, but it has to be.
Yeah. I mean, another area where the internet's been absolutely priceless in lockdown has been supporting entertainment video, which again is a different set of trade-offs versus video conferencing. You know, I actually remember Dave Sinkowski, who we both worked with back in my first job at Belcor, wrote a paper about whether video on demand was technically possible. And I think he would have written this right around the time that you and I met in 1990 or so. And it was a very bold paper suggesting that maybe video on demand could work across the internet. Of course, today, you know, we absolutely take that for granted. But it's not that long ago that Netflix was, you know, shipping us DVDs in the mail because that was a more efficient way to get content to us than streaming it over the internet.
Yeah.
And today, you know, it works incredibly well.
Yeah, I shouldn't confess this, but I was an expert witness once in the federal district court trial of the folks that ripped the DivX, if you remember that, the video.
Yep.
And I testified as to how bad congestion was on the internet, and there wasn't any real practical way that any harm could be done, because who could possibly transmit the videos over the internet?
Yeah, and there's a story I've heard about the DVDs versus the streaming, going back to a textbook that probably you and I both learned from, where there was it was an exercise where you could take a magnetic tape and put it have it carried around by a Saint Bernard dog. And the idea was that the dog carrying the tape was actually moving data faster than most networks. And I think that was the idea of Netflix, was like, it actually was faster to take a DVD and stick it on a truck in terms of the bits per second, rather than actually, you know, sending the bits over the network. Clearly that equation changed in the last few years. You know, these days, obviously the video streaming over the internet is just extraordinarily good. And as you say, it's partly because the bandwidth have gotten better. But again, there's some pretty interesting stuff with the relationship between coding and congestion control, again, in the video streaming world.
Yeah, there is. And well, so there's obviously a lot going on there. It makes you wonder what will be next. And we are now in a video mindset and video and streaming and conferencing, but, you know, will that become passe, and will there be something else that overtakes it in the importance?
Yeah.
I mean, networks have latency, and networks have a sometimes not terribly predictable latency.
Yeah.
Anything, if you're going to do mission critical, maybe not the bandwidth end of it, but maybe both the density of the devices communicating, their mission critical real time latency requirements.
Yeah. Yeah. I mean, the issue of latency comes up a lot in things not related to entertainment so much. Although I guess gaming is one where latency comes up a lot, right? That you definitely don't want to be firing your trigger and having a half-second delay before the missile fires or whatever. I used to be very much into gaming when I was a student before I met you, and I realized at some point I had to give it up because it was just let's say I had a bit of an issue. So I just stopped playing video games at about age 21, and I've never gone back because I'm afraid I would just lose all that time again. But obviously, gaming is one of those areas where the desire for low latency comes up, and I guess you hear stories too. I don't know if you get this at your house, but you hear stories about sort of competition for the bandwidth between the different members of the family, and the kids playing the games are the other ones.
Yeah, I've experienced that. One of my kids was in Japan for 5 years and came back and moved back with his folks for 6 months, set up his gaming system, and he owned the network.
Yeah. Yeah. So one of the things that you and I worked on was quality of service, which I think I'm still ambivalent about how that really played out. But clearly that was one of the use cases. Would be you could control the allocation of bandwidth between say the important work that dad's doing on his computer for home, from home, and the less important work that the kids are doing on the game, or maybe vice versa, depending on your priorities. I feel like an enormous amount of work went into trying to build mechanisms to get QoS into the internet. And today, by and large, they're not being used. But I don't know, maybe it's different in the part of the world where you work.
No, well, yeah, it is. And I've always been one of those people that sort of believe maybe if you just give it a little bit of time, the network will get fast enough and the endpoints can adapt. And we certainly saw that with Netflix. They really changed the equation in terms of the ends adapting instead of trying to do QoS in the network. But I still have to be completely convinced because all my biases point me the other way. But I think QoS in the cellular network might be a different game just because of how what a scarce resource it is. Mm. And again, as you start to try to mix bandwidth with predictable latency, the scheduling is where all the intellectual property and secret sauce and magic happens.
Yeah.
One
of the topics that's come up in terms of how well the internet's been doing during lockdown is the fact that we have seen people engineering it to deal with quite unpredictable things. And the sense that putting in those QoS mechanisms was all about trying to make things really predictable. And what a lot of people figured out was, it's just easier to throw some extra capacity in there. And there's kind of an interesting comparison between how the internet is run versus how almost any other system that we deal with, there isn't tons of extra capacity sitting out there in the interstate highway system or, in the hospital system. There's not excess capacity because, it just feels too expensive. But yet the internet has tended to be built with this kind of excess capacity, with the result that it's there for the really, really busy hour, which I think, once upon a time that would have been probably people watching movies on Saturday night. A year ago, that would have been the busy hour in the internet. Now, probably we're in the busy hour right now of the internet. It's like when, people are doing all their Zoom conferencing during the workday, it's probably now becoming the busy hour.
Yeah, I think that's probably right. That reminds me, what happened with Slack yesterday? Have you heard?
No, I haven't. I'm actually eagerly awaiting the post-mortem on that because, one of the things that's been impressive, all these cloud services that we all depend on, Zoom included, scale out incredibly well. Yeah. And I think that this is one of those things where it's more in the realm of how software development has changed over 30 years, that people build systems now to have unbelievable ability to scale. And, seemingly Zoom has gone with barely a hiccup in terms of how well it's adapted to all of the additional load. And clearly something didn't perform yesterday in Slack.
Yeah, I depend on Zoom and I depend on Slack, and I really felt it when Slack failed me.
Yeah.
It will be interesting, but you're absolutely right. I mean, I don't know, this is networking, it's cloud, it's networking. If you can't get more capacity out of the network, you just replicate space and you put more of the internet at the edge where you live. That's kind of what the cloud's doing for us.
Yeah, but yeah, I mean, I had to think that somewhere in Slack there was some component yesterday that became a bottleneck. And generally speaking, you build these sort of cloud native systems to not have any single bottleneck. And clearly, something yesterday became a bottleneck. And
well, probably what became a bottleneck was some operator who made some configuration change.
Yeah, that's a good bet actually. I mean, that's as we know, a lot of the things that go wrong with networks tend to be where humans get involved and make ill-advised configuration changes. That actually kind of is one of the things that's been I think very, very interesting in the SDN world. How we've moved to a world where more and more of networking is software talking to software. That if you think of all the things that humans tend to do wrong in networking, it tends to be, I've got this very, very complicated configuration I have to get exactly right. And if I type one character wrong, I can bring down a big chunk of the network. And so the more that you can have that task done by a piece of software, obviously software has bugs too, but you can at least have things be more predictable and take out those sources of human error. I remember being at a talk by one of the people from Facebook talking about the fact that he is absolutely confident that robots would do a better job of running his network than humans. And so I think that is one of the things that's happened with networking over the time that we've been involved in it, is this idea that it's gone from being something where manual configuration by human experts is increasingly being replaced by automation done by software.
Yeah, and it's interesting. It shifts the problem. One way I think about SDN is it's transformed a networking problem into a distributed systems problem or a scalable systems problem. And in that setting, one of the things that I keep coming back to is it's not so much the congestion control algorithm that's still important. It's not how you get reliability of the network that's still important. It's how you operationalize the network. And that comes down to how you configure it. You track changes to configuration. That's where the center of gravity is in many networks that get rebuilt this way.
Yeah. The other thing I was thinking about, and you kind of reminded me talking about Slack, is that we've been involved with the internet since before there was a World Wide Web, and you can remember that there was this sort of period of people trying out lots of different ways of moving information across the internet, and we used to do things like FTP, and there were a few other things like Gopher that are a bit more esoteric, and at some point HTTP just became the kind of dominant way to get stuff across the internet. And clearly we've benefited enormously from the success of that. But I think one of the things that I feel the early internet architects and pioneers really got right was the idea that the internet should support any service, even all the ones we haven't thought of yet. And in contrast, for example, for how the telephone network was built to do phone calls and the cable TV network was built to do television, the internet was built to do anything. And going all the way back to email, there have been all these ideas that nobody had at the time that turned out to be incredibly successful. I think Slack's one of those examples. It's like, who would have thought that messaging could really be still an area of innovation in 2020. But I don't know. What do you think about sort of how well the internet's done for enabling innovation?
Well, you're absolutely right that it was a general purpose thing, and that's what as I've learned more and more about the evolution of the cellular network, and you look as the transitions from 2G to 3G to 4G and so on, every one of those was just adding maybe a little bit more degree of freedom to what we consider this specialized network to do. And that's why I actually think 5G is maybe the most important change, because it now finally says, oh, it's just part of the cloud. They don't say it that way, but that's really finally coming to the realization that it's no different than anything else. It's part of the cloud. And at that point, then you can start to bring all of these other best practices in building new functionality to play.
Yeah. So I wanted to just talk a little bit about sort of where we think things might go in the future. Every year, roughly, I write some kind of predictions post, and I'm feeling pretty good about the one I wrote this year because I went back and looked at Bob Metcalfe's prediction that the internet was going to collapse, which was, I think, sometime in the 90s, not 96 or so. And Bob Metcalfe, absolute legend in terms of his contributions to networking. But on that particular occasion, he made a very bold prediction, which was spectacularly wrong. So I wrote this post a few months back, sort of predicting that the internet would continue to be resilient and continue to evolve to meet emerging needs, which maybe wasn't such a bold prediction, but it turned out to be a bit bolder than I realized, given the amount of stress. So like, I'm feeling good. Like, A, I'm happy to be right, and B, I'm really happy that the internet's working right now. So anything you would care to predict in terms of like what we might see in the next few years of networking?
Well, I could do a stretch prediction, not much because I'm pretty sure it's going to happen, but I would like to see it happen. And that is, and it goes back to SDN a little bit, which is people are now programming the network data plane. And maybe work about languages like P4. And what intrigues me about that is that the network device becomes commodity, just like the PC became commodity. And you now get to program it with a pretty general purpose programming language. P4 has a lot, it's specialized a little bit, but it's a lot like C. And now anyone can do it. And it really, really shifts control of the network. I mean, right now we're in the transition where controls, maybe we're trying to get control moved from the vendors to the operators, but it really belongs from the operators all the way to the users, not your average, unvoiced masses users, but the people that have innovated and written interesting code and useful applications on, the x86. It really is going to open the door for them there. And, again, this is the kind of in the limit prediction. I would never put a date on this, but eventually, we're going to have different kinds of processors. Some of them are really good at AI. Some of them are really good at shuffling packets from input and output. And some of them are good at polygons. And they're just going to be a bunch of processors out there. And they're all going to be programmable. And that's just going to completely change the way we think about the network. That's so far in the future, I'll never be held accountable for it. But
yeah, I mean, I think one of the things that I feel fairly good about is that most people these days don't think too much about what the network's doing. That I feel like we've gotten to the point where you had to be some kind of wizard to even get on the internet, to one where it is as a service, it's just sort of a commodity that we pretty much take for granted, except of course when it goes down. One thing that I found interesting when I moved to Australia was that we've got a much more competitive market for internet service providers here than, say, in the US, because of the way they designed the network here. So when I decided to get broadband service in my home, I had a choice of about 75 different internet service providers. Wow. Because of the fact that there's one company that has the right to bring a physical cable into my house.
Right.
But then, on the order of 75 different companies have the layer 3 service that runs on top of that.
Right.
And that's been really interesting to see how that's played out in terms of the operators having more control over what kind of service they give. They can do things like, just offer a large amount of capacity. They can offer you things like, I wanted to make sure that I could not have double NAT being done to my address, which is like, that's a pretty exotic thing to care about. But they sent me an email saying, we're introducing, carrier grade NAT. If this bothers you, let us know. And I sent them a note saying, yes, this will bother me. It'll stop a few things that I depend on from working. And it's like, wow, who would have ever thought of a internet service provider caring enough to ask you about carrier grade NAT?
Oh, that's fantastic. Yeah.
The set of people who believe that's a good feature is very small, but I've got to tell you, that's one of the ways which my ISP won my heart, was that they didn't just go and introduce it and not tell me. They told me it was coming and asked me if I cared. And then simple matter of an email explaining why I cared to get that feature not turned on for me.
Wow. Yeah, I'm envious.
Yeah. I always like to talk about how great the broadband is in Australia, because almost every Australian thinks it's terrible. And it's just because there have been some aspects in which it hasn't been what we were originally promised. But that aspect of competition between the ISPs, it's so different than what I experienced living in the US, where I think I had a choice of 2 ISPs, effectively a duopoly. So anyway, I always like to say, well, maybe not everything's perfect, but they got that one aspect of it right.
Yeah, that's fantastic.
Yeah. Look, I think we've had a pretty good long chat here. Any parting thoughts on the world of networking before we wrap it up?
Well, I mean, as someone who, we both worked on this textbook for many, many years, and part of that was about to train the next generation. So I guess the only other parting thought I had is that there are a lot of changes coming, and I know that we've been thinking about how we teach networking and how that needs to change. I think the old style is served us very, very well. And it didn't really matter if you were going top down or bottom up. It was kind of the same story, a little bit different packaging. I think the story is on the verge of changing substantially. I don't know exactly how, but I do think that that change is coming. And as people who are interested in teaching that, we have to figure out the right way to deliver that material.
Yeah, absolutely. And I mean, clearly, just right now, we're all living through a very strange time in terms of how people learn, with, online learning becoming almost a requirement. And after a few false starts with online learning in the past, I think we've got to figure out how to get that to work. Well, I guess this is the next project for you and me, right? Is we figure out how to train the next generation in some method other than just churning out a textbook every few years.
Yes, that's exactly right. Yep.
All right. Well, Larry, I'll say thanks very much, and I'm a bit envious of the beer, but I'll hold off for a few more hours. Great to see you, and we'll talk again soon.
All right. Bye-bye.
Perfect.